Well, Algebra Geometry 3 classes, good morning, good afternoon, or good evening. I realize whenever you are happening to watch these may be completely different for everybody. But we are going to continue in Unit 6 with absolute value. I know in 6.1 we were working with absolute value equations. In 6.2, one of the things we're going to look at are absolute value inequalities. I know back when we looked at Unit 7, the linear programming unit, we were graphing linear inequalities. That's where we were using solid and dotted lines. This is going to be something kind of similar to that, except instead of graphing lines, we are only going to be graphing on a number line. But it is a similar idea there with that. So again, just a reminder, absolute value. When we talk about absolute value, it is the distance a number is from zero. Now, the only thing that's going to change in this section is we are going to look at inequalities. And when you're working with inequalities, you can have absolute value ax plus b is less than c. Now, again, remember, it does have to be positive. If you don't have a positive number, there won't be a solution at all, because absolute values cannot only not equal a negative, they could not be less than or equal to a negative. So when we have that, essentially what's happening is you are going to have two separate quantities that you're working with, much like where we use both the positive and the negative. Absolute value ax plus b is less than c. We have to work with ax plus b is less than c as is, and ax plus b is greater than negative c. Now, the reason we flip that is when you multiply or divide by a negative, which is what's happening when you go from c to negative c, you flip that inequality. That goes back to algebra geometry 1. And again, when you have ax plus b is less than or equal to c, well, much like the other one, you're going to have ax plus b is less than or equal to c, and ax plus b is greater than or equal to negative c. The only thing that changes is whether or not it's just a greater than or equal to. So, for example 1, absolute value x is less than 3 means you're looking for all of the numbers that are less than 3 units away from 0. So again, if we're going to set this up similar to what's here, we are going to use x is less than 3 and x is greater than negative 3. And that's what this is saying right here. The set notation, x is greater than negative 3 and x is less than 3. Now, one of the other things that we will often have you do is graph these on on a number line. When we graph these, the main thing you do want to be careful about is make sure you list them in order. Positive 3 goes there, negative 3 goes there. Now, I know it's been a little while since we've talked about whether you use the open or closed circles. If it is less than 3, greater than negative 3, I am going to use an open circle. Now, from there, this first one says that x is less than 3. Now, again, if you remember going back to Algebra Geometry 1, that means we're going to shade or draw the arrow if it's less than to the left. Now, when it says x is greater than negative 3, we are going to draw an arrow to the right, and then we are going to connect. Now, the last thing, if they want your answer as an interval, our interval will start at negative 3. It will stop at positive 3. If you have an open dot, that means this number is not included. So for your interval, to show things aren't included, we use parentheses. So this is your interval notation. Here is your number line, and then here are your set notation answers. So that's, a fairly easy one to kind of get us started. Now, as we work with the next one, absolute value 2x minus 9 is less than or equal to 7. Well, first, we just rewrite it as is without the absolute value. our second inequality, 2x minus 9, now we're going to do two things. First, we flip this to greater than or equal to, and you change the 7 to -7, because when we work with absolute values, you will end up with two solutions. So from here, now we just solve each of these algebraically. So add the 9. 2x is greater than or less than or equal to 16, and divide by 2. X is less than or equal to 8. Also, add the 9 over here. 2x is greater than or equal to 2. Again, divide your 2. X is greater than or equal to 1. Now, before I worry about my intervals, I like to, again, set up our number line. Again, do make sure you put them in order on the number line. The 1 goes first, the 8 goes second. You don't have to worry about any other numbers labeling there. Now, biggest change from example 1. When these are less than or equal to, greater than or equal to, we are now going to use closed circles or closed dots. And then this one says x is less than or equal to 8, so I'm going to draw my arrow to the left. This one says x is greater than or equal to 1, so I'm going to draw my arrow to the right. And again, they connect. Biggest change for our interval on this example, it starts at 1, it stops at 8. If you have closed dots, that means we are including these values, so I am going to use brackets there. So biggest difference there again is if it is less than or equal to, brackets, when it is just a regular less than, parentheses. All right, example 3. Biggest thing that changes here. If you have a number outside of the absolute value, you need to move it first. So that's going to give us absolute value 5x minus 9 is less than 16. Now, from here, we can set up our two equations, or two inequalities. 5x minus 9 is less than 16, and 5x minus 9 is greater than -16. And now we just go ahead and solve these out. Add 9. So 5x is less than or equal to 25, and divide. So one solution is x is less than 5. For our other half, we are going to add 9. And divide. Our other half of the solution set is that x is greater than -1.4. So, do not be surprised when you do these if one of the answers ends up being a decimal. So, to finish this one, again, we are going to set up our number line. Now, the two numbers we found, -1.4 and 5, so we do want to list the negative number on our number line first, the positive number, which is larger, second. Because these are not equal to, we are again going to use open dots. Now, the first one, or this one, says x is greater than -1.4. So I'm going to draw my arrow to the right. This one, x is less than 5. I'm going to draw my arrow to the left and connect. Your interval goes from -1.4 to 5. And again, because these are not included, we are going to use parentheses. All right, a couple of final examples. For this next one, absolute value 1/2 x plus 4 is less than or equal to 5. Well, once again, we are going to just set up our two inequalities. Going to make this one greater than or equal to -5. Now, from here, as you solve these, first subtract 4. 5 minus 4 is 1. Now, I don't actually like to divide by a fraction. You can. Instead, I prefer to multiply by the reciprocal. The reciprocal of 1/2 is 2. So then x is less than or equal to 1 times 2 is 2. For our second inequality, we're first going to subtract. -5 minus 4 is -9. Again, multiply by our reciprocal. 2 times 1/2 cancels to just x is greater than or equal to -9 times 2 is -18. Just like the others, to finish, I am going to now set up a number line. My -18 is going to go first. It's the smaller value. +2 goes second. These are greater than or equal to, less than or equal to. So I am going to now use our closed circles for these. For less than or equal to 2, going to draw my arrow to the left. For greater than or equal to -18, that would go to the right, and then I can connect. For our interval, it starts at -18, it stops at 2. Because we are using closed dots, brackets there. So that again is example 4. One final example. Absolute value of x is less than or equal to a -12. Well, just like when we were solving equations, absolute values turn everything into positives. Well, because absolute value turns everything positive, a positive can never be less than a negative number. So if you ever have one of these where you start out with it being less than or equal to a negative number, this is automatically a problem where there is no solution. Probably the better news even for this one, if there's not a solution, you don't have to worry about an interval, because if there's not a solution, there can't be an interval. And if there's not a solution, there is nothing to graph. If you were to graph it, it would just be an empty number line. So all you have to do for one like this is say it's no solution. There is a 6.2 assignment on School of G for these style of problems as well.